So what do we do with these arms? Because this is something that is probably not super well known, is the arms, mostly the SSRMS, but also the SPDM, have certain functions that are key to the life of the station, as I say from the beginning. So in this chapter, ISS Robotic Tasks and Functions, we are going to see what were and what are the main functions of these arms. So for instance, the main function of these arms throughout the construction of the ISS was to build the space station. The modules came up with the shuttle, and either the modules or the truss or any parts were in the trunk of the cargo bay of the space shuttle. It has to be moved out of the space shuttle cargo bay via a certain arm, and then the other arm will take over and put it in the right place on board the station. So this huge Lego was only possible thanks to the usage of the arm. Here on this picture, for the ISS assembly, you see Columbus Laboratory, which is the main laboratory for Europe and the main module for Europe, is taken out of the space shuttle cargo bay by the SSRMS and is moved towards its final location. So that happened back in 2008, and this was a main event for space in Europe. Now, if we look at this video that we have here, this is actually, I will not show you the entire assembly of the station, it's not the point of this, but this is an interesting feature where the biggest space station module arrived, which is the Japanese laboratory, was taken out of the trunk of the space shuttle and was moved into place. The video you will see, it's also backdated to 2008, and this movie is in an accelerated format to show you how big and how, in which complex environments we were evolving the arm throughout. So in this video you see, for instance, the arm moving into position and ready to grab the Japanese module. So it's taken out, it's rotating, and it will be slowly put in place. Then it's going to be, it's turned and it's translated, and then it's approached to the station, and then slowly, when it's going approach to the station, it will be birthed towards the station in a very accelerated format. So at the time this module was installed, the module was in something in the order of less than 20 tons, something like 15. Now fully fledged with all the experiments, it's way heavier. Now the arms and the SSRMS was not only used to build the station. Now the assembly phase is over. Since 2011 we declared that the space station is complete. But the station is aging. The station has equipment that can fail or that need to be inspected. And one of the functions of the arm is actually to make sure that everything which is outside of the station is as you expect it to be. And the other way around, you want to make sure that your arm, which is a key asset for space station life, is still fine and up and running. So one of the tasks of the SSRMS, as well as also a bit of SPDM, but a little bit less, is you pre-position the arm. As you can remember from the red area, you can nearly reach all possible places on board the space station. So you use the arm to observe certain structure, certain payloads, certain wires, certain cameras, certain whatever you want. So you approach the arm because the arm has itself cameras mounted on it. The SSRMS had 4 cameras, and you can use the arm to get close to what you want to see. You observe it, you can zoom, you can even move around because the arm is pretty flexible. And we will see later on how the arm is practically built. So the arm is used for inspection, and as I say, it's also a mirror. You can pre-position the arm in front of a space station window, and the crew as well as the ground is using also some cameras to observe if the different parts of the arms are all working in a fine order and nothing has to be done. Recently, not later than actually 10 days ago, there was, and even last week, there was a big maintenance of the arm necessary, and so the crew has to get out of the space station, do a spacewalk, and they repair the arm following one of the inspections where we realized that one of the key components of the arm was not really working in the right order. Another important task of the arm is to do maintenance and repair. So the station has been assembled like a huge Lego for about 13 years. And what I can say is everything, of course, will fail. Everything at some point will have some defect and needs to be replaced. So in that picture that you see here is we have the ISS armrest, which is almost not in the view. So from the lower part of this picture is holding the SPDM, so the Dexter, the fine arms. So it's holding Dexter by the body. And then Dexter is making some repair operations. So it happens already last year, and it happens very often that we use, for instance, these robotic assets to exchange part of the batteries or power components outside of the station. So we use these little arms of SPDM to extract an old battery and replace with a new one. And the same with power cards that we have. It's not always possible to do all this with using only the robotic assets. So sometimes, for instance, for the battery repair, which happens a couple of months ago, you cannot do all that using SPDM and SSRS. You need at some point the crew to get out of the station and removing one of the components, getting them ready for the arm to grab it. Or you take it even yourself and you put it onto the arm. That's something that happened already several times. So it's a kind of ballet between the robotic aspects as well as the spacewalk. So we maintain the system, we maintain the station using the arm, and we repair some part of the station using the arm, but also it's a collaborative work with the crew outside when necessary. So on the next topic, what the arm is good for, it's EVA support. So for instance, on this picture, during the assembly time of the station, you see that on top of the arm, we have a crew member mounted on a certain platform, and the crew member is holding a payload. And what the crew member does is just holding it. And then the arm is moved to the good position where the crew member in the suit can assemble or put this payload at the final destination. So this is a collaborative work where the arm itself maybe could not have taken the payload by itself, and the crew could not have translated all the way from one place to another just by holding this huge cube that you see in his hand. So that's exactly what we mean as collaborative work. And for spacewalk, it's very, very often that we use the arm to support the spacewalk. Not only to do the repair work, as you can see on this picture. So for instance, on this picture, we had to go beyond the red area that I mentioned at the beginning of this presentation. So you see the crew member is repairing the solar panels, which are on the far side of the station. And because it was out of reach of the arm, we had an extension here. So the arm is in the middle left of the picture, as you can see here, and is attached or is grabbing an extension boom from the middle, and then at the top right from this extension boom you have a crew member who is attached, and then is repairing the solar panels with the wires. This happened during the space station assembly, where when we were folding back solar arrays and redeploying them, and there was one tear in the solar arrays, and then it has to be bypassed so that we can still extract power from after the tear. So this was an important, and this is still an important asset and function of the robotics, is to support spacewalk all the time. Something which is also becoming very important, because what we are trying to do lately these years is we try to minimize these spacewalks, so that when there are new payloads or new equipment coming up with vessels, cargo vessels, we don't want always the crew to get out of these vessels, take these experiments or this payload and put them at the right place. It costs a lot of money, it costs a lot of crew time, and it's always dangerous to do a spacewalk. So we try to do all that using robotic assets. And usually it's done in tandem. So we have on this picture, for instance, you see Dragon from SpaceX. We just arrived to the station and it's attached to the belly, so to the bottom of the station. And Dragon has two parts. It has a conical part, which is the pressurized vessel. And the pressurized vessel is where the crew is coming in and taking cargo out and then put cargo for return in. And then you have a cylindrical part where the solar panels are. And in there, inside this cylindrical module, you have some unpressurized cargo that was brought up by the vehicle. So the SSRMS is holding Dexter, so SPDM, and Dexter is getting inside the cargo trunk, get the payloads or the experiment out, and then move it to the right place. So that's unpressurized payload are usually brought up to the station this way and are also mounted that way using robotic aspect. One also way to bring up unpressurized payload is not only to use SpaceX and Dragon, but you can use also the HTV, which is the pressurized and unpressurized cargo vessel from Japan. Has also a kind of drawer. And this pallet drawer has to be unmounted sideways from the vehicle. So the SSRMS is taking this drawer and on rails and slowly pulling it out of the vehicle, then moving away from the vehicle. And then when it's moving towards the Japanese module, and the Japanese module, here it comes, the GEM-RMS, so the other arm on the station, is taking the pallet and picking up the different payloads that you need to install in front of the Japanese module that you can see the exposed pallet. So it's a kind of two hands operation where one arm is taking the pallet out, holding it, and the other one is picking up, like a cafeteria where you pick things on the tray. So that's how we bring up materials experiments or replacement on board. But something where the robotic assets has become crucial lately these years because we have less Russian cargo ship Progress flying up, and ATV, which was the European cargo ship automatically docking to the station, has been yet discontinued, so there is no European cargo ship anymore. And on top of that, since 2011 we don't have the space shuttle flying. Most of the cargo going up to the station is flying via SpaceX, Orbital or Japanese HTV. And these cargoes, none of them will be able to dock to the station by themselves, so they need the arm. So in that case, what these vehicles do is they arrive very close to the station and they hover something like 10 meters below the station, and the arm doesn't grab this payload by itself. It's the crew who will take control of the arm and flying the arm towards the vehicle to grab them. So it's a track and capture approach. That's the jargon that we use. The crew is highly trained for this, and they do these operations so that the crew does it instead of the ground for reaction time, because if the ground will do it, there will be too much delay between the ground and the space station, and for that you need a quick reaction time. To have an automatic grabbing of the payload, this is something that it's maybe for the future, but for the time being the arm is not able to automatically grab the payload or the visiting vehicle. So here you have a picture of HTV approaching, and it's seen from the window. And then here it's another example of Orbital, which is another private company. So Orbital is the company launching Cygnus, is the name of the cargo ship. And Cygnus, as you can see here, is approaching the station, and the crew is getting ready to grab that vehicle actually from the back. Then once the grapple has happened and the crew has grabbed the payload, then the ground will take control, and then the visiting vehicle or the cargo will be mounted slowly to the station. So it's usually an operation which is done by the ground. So the ground is then flying the arm and slowly is moving the new arrived module to the station. So here you see, for instance, during night operation, the arm slowly berthing. So the name of this operation is berthing, not docking. Docking is when it docks automatically. So when the vehicle itself is moving itself into the station or towards the station. Berthing is something which is done by the means of robotic arms. So you really use the arm to berth the vehicle to the station. And here you see the final phase of the berthing, where Dragon from SpaceX has been attached to the ISS from the bottom of the ISS. So it's a bit disturbing because you see the Earth at the top, so the station is actually always showing the same face to the Earth. So usually visiting vehicles are coming from below and they are berthed from below the station. That's a key function because you will have this chain of supply interrupted. So if one day we don't have a resupply chain for cargo, then the operations on the station will stop because we will lacking food, we will lack water, we will lack oxygen, even though we recycle a lot of this. This track and capture and grabbing a visiting vehicle is now probably the bottleneck of the space station operation. If the arm will not be able to fulfill this function, then you are in big trouble. You are in big trouble because they are not only breaking the supply chain for equipment, but also for food, and space station operation will have to be discontinued, or we might have to reduce the number of crew on board to maybe 3 or 2, relying solely on the Russian cargo, which are the only one then to dock to the station without the arm.